As one of the most perplexing things in our universe, black holes certainly deserve all our attention. In this video, we will investigate black holes until we gain a clearer understanding of what they are and how these marvelous mysteries can recast our relationship with the universe. Despite what the name might suggest, a black hole is not all empty space, but rather the opposite. It is a tremendous amount of mass packed into a tiny volume. Because the force of gravity on an object increases as the mass of the object increases, this immense amount of matter in a tiny space results in a gravitational pull so strong that nothing can escape the black hole, not even light. Most black holes form as a result of the death of an enormous star in a supernova, which is the term we use to refer to the explosion of a star. A supernova is the largest explosion that takes place in space. You may be wondering how such an explosion leads to the creation of a black hole, but in order to understand this, we must first analyze the life cycle of a star. Stars are born from hydrogen gas clouds called nebulae. It is likely that you've seen this image from a portion of the Eagle Nebula, famously known as the Pillars of Creation. Inside these hydrogen clouds, gravity causes the collapse and accretion of matter, which leads to the formation of a star over the course of thousands of years. In its earliest stage, this contracting mass spins faster and faster, leading to temperatures high enough to prompt nuclear fusion. Nuclear fusion converts hydrogen atoms into helium in the core of this star, and this process releases massive amounts of energy which the star uses as its fuel. This nuclear fuel is in the form of radiation that pushes against gravity in order to maintain the star's stability. If the star has a core with a mass much greater than the sun itself, then nuclear fusion can form even heavier elements including iron, which is unlike any of the other elements that were produced prior in the core, whereas nuclear fusion for iron releases zero energy. Recall that a release in energy in the form of radiation is vital to opposing the force of gravity, and in doing so, maintaining the star's stability. However, as iron continues to build up in the core without releasing energy as a byproduct, gravity overwhelms all the other forces until the star's core collapses and a supernova explosion occurs. What remains is no longer supported by the generated energy, so it then collapses under its own enormous weight to a point where it bends space to such an extent that the entire mass plummets into a hole. So, are black holes real or are they purely theoretical? With his general theory of relativity, Albert Einstein first predicted the existence of black holes in 1916. Over a century later in 2019, the Event Horizon Telescope collaboration captured and released the first ever image of a black hole. When looking at a black hole, you'll see its event horizon, which is the outer boundary that light cannot escape past. Once a particle crosses over the event horizon, it can no longer escape the black hole unless it travels faster than the speed of light, which humans understand to be impossible. The inner region of a black hole is called the singularity, and it is the single point in space that contains its enormous mass and its tiny volume. At the point of singularity, gravity becomes infinite, and the laws of physics as we know them can no longer be applied. It now seems appropriate to say that the more we learn about science, the more we come face to face with its limitations. It is a common misconception that black holes suck in whatever is in their vicinity. Instead, objects fall inside black holes just as they fall toward anything that exerts gravity, like the Earth. Though physicists are not completely sure what would happen if you fell into a black hole, it is a popular theory that gravity would stretch you out into your tiniest particles via a process labeled as spaghettification. There are also physicists who remind us of the possibility of multiverses in our discussion of black holes. It is often suggested that if you stumble into a black hole at the center of the Milky Way, there is a chance that either you, or at least the particles that once composed you, will end up in a different universe. Thank you guys for watching. If you learned anything new about black holes, make sure to leave it down in the comments below along with other video topics you'd like to see. And make sure to leave a like and subscribe for more content. Thanks again!